Hello folks, and welcome to this lesson on the organic nomenclature of unsaturated hydrocarbons. By the end of this lesson, you should be able to name and draw alkenes and alkynes with various side chains. So last time we dealt with the alkanes, which are referred to as saturated, and this time we're going to be dealing with some unsaturated hydrocarbons. Now, you've probably seen these terms somewhere in your life before, probably in the context of nutrition, because we have things called saturated fats and unsaturated fats, and whereas in a lot of science you have words having different meanings when it comes to typical language, this use is actually the same use as you would when you're talking about saturated and unsaturated fats. So if you remember, saturated means you only have single bonds between carbons. Unsaturated means that you can have double or triple bonds between those carbons. Now, having those double and triple bonds can change the VSEPR shape and the electron density around those bonds, and because of that, the physical and chemical properties of these unsaturated hydrocarbons are different compared to the saturated ones. I'm not going to talk about these differences right this instant, but they are definitely going to be showing up in this entire series of lessons on organic chemistry. First off, we have our alkenes. Alkenes have one or at least one double bond between carbon and carbon. The general equation for an alkene is going to be CnH2n. If there is only one double bond in there, if there is more than one double bond, of course the number of hydrogens are going to change. What happens in the naming itself is that you're going to use those base alkane names, but then change the ending to -ene instead. Now you can also have alkenes and alkynes with other different types of functional groups as well, but we will look at what those names look like later on. Now here is where you need to start being careful with that naming and numbering, because you have to make sure that your parent chain contains that functional group. And with numbering, it's not just numbering with the lowest number combination for your side chains. You have to consider the lowest number combination for specifically your functional group. So you might end up with a number combination that is higher when it comes to your side chains, but if it's the lowest number combination for the functional group itself, then that's a naming convention that you're going to go with. And so let's start touching upon those differences when you have these double bonds. So we have our carbon here and we have our carbon here. Our carbon has 3 electron domains around it, so that means instead of being a tetrahedral shape, we now have a trigonoplanar shape. And that angle is going to be 120 degrees. Now this is pretty different from your alkanes, where remember you have that tetrahedral geometry, and so you can see there's a lot of geometry going on when you don't have double or triple bonds. However, as opposed to that, we have the trigonoplanar geometry when you have a double bond, and so it is flat, and then you have those what would be 120 degree angles. And something for you to note as well is, if you take a look at our alkane, you can see that these spin. They turn around, and so you can have a lot of shapes twisting around in space. However, depending on whether you have dealt with sigma and pi bonds, remember that if you have a double bond, you have a sigma bond between those carbons, and then you have a pi bond as your second bond. The pi bonds make this bond rigid, so there's no spinning that can happen around this bond. It's going to be very rigid and it holds its shape. And this has consequences to some of the naming aspects as well, though we're not going to deal with that in this particular lesson. So here we have 2 different alkenes. If we were going to name them, well, we only have a single chain, so it's not going to be very complicated. This has 1, 2, 3 carbons, and so it's going to be based on propane. Because it does have that single bond, it is not propane, it is propene. Now here we have 4 carbons, and so it's going to be based off of butane, but it is going to be butene instead. Now, here is some of the weird stuff that happens when it comes to 1. The number 1, that is. Now, in this case, this is propene. The end. However, you may notice that I have very conspicuously left a space here, and that's because this particular compound is but-1-ene. Now, the reason why this is but-1-ene and this is propene is because if you have a propene, there is literally only one place that single bond can go. It is literally always going to be on carbon 1. Because if you want to argue, well, what if I put the double bond on this side? Wouldn't that be your propene? Well, or wouldn't that be prop-2-ene? Well, no, because if you put it on this side, you're going to have to number your carbons. And so it'll be 1, 2, 3 or 1, 2, 3. But if you put 1 here, then this becomes 2 for the double bond. Whereas if you put it here, this will be 1 for the double bond. And that's going to be the lowest number combination for your double bond. So no matter what you do with this propene, that double bond is always going to start on carbon 1. And so propene is just propene because there's literally no other way that you can draw propene. However, with the butene, it's a bit different because you can put that double bond between carbon 2 and carbon 3 instead. So this time you can see, oh, it's definitely in a different place in this butene. So we definitely need a way to name this differently from that. So for this one, it's symmetrical, doesn't matter which side you start from. This is always going to end up being but-2-ene. So because of the fact that you can have but-1-ene and you can have but-2-ene, you have to put the 1 in this case. So once again, in this case, there's only one possibility for where that double bond is going to be. So no 1. In this case, you have to be able to distinguish between the different places the double bond can be, so you do put in the 1. Also, as you may have noticed as I was going through this, you number your carbons, and then the number that the double bond comes from is the lower number between the 2 carbons. Here's an example of one to draw. Let's take a look at the name. Here's our parent chain. We know that it's going to have 5 carbons because it's pent something. So 1, 2, 3, 4, 5. We know that we have ene, so that means we have a double bond in here and it's on carbon 1. So it starts on carbon 1, goes to carbon 2. And then we have to deal with our side chains. We have methyl groups. In fact, we have 2 of them, and then we have 1 methyl group on carbon 2 and 1 methyl group on carbon 3. Here's the structure. Pause the video, try and name it. So first off, let's identify our parent chain. Now, the temptation for this particular structure is going to be going this way because this will give you the longest chain. However, this longest chain doesn't include important functional groups. This is that important functional group that we need to make sure that we include. So that means our parent chain has to include this, and then from here we choose the chain that is going to be the longest, which in this case it doesn't really matter. Now, you can't say, oh, it's all of these are part of the parent chain. You can't say that because of the fact that then you don't have a single chain that contains your functional group. You have branches, and we're just trying to find the longest parent chain. So here we go. We have our parent chain. We can start naming from numbering from this side, or we can start numbering from that side. The choice when it comes to numbering is going to be 1 being over here. The reason for that is our double bond is here. We need the lowest number combination for the functional group. And so we need to start 1, 2, 3, 4, as opposed to going 1, 2, and then the double bond being on carbon 3 instead. Our side chain, here we have an ethyl group. So let's put our entire name together. The first part of a name that is relevant to our compound is the side chains. So this is carbon 1, 2. Our ethyl group is on carbon 2. You're not going to put anything like mono because some of the redundancy with 1 issues that you've seen before. And then we have our butene because that's 4 carbons. So no space, but-1-ene. And that's the name for this one. Now the second type of compound that we're going to be dealing with, or second type of functional group, is our alkynes. Alkynes refer to triple bonds, and so an alkyne would have at least one triple bond. You basically take the base name, change the ending to YNE, and again, we're going to look at geometry a bit. So here we have our alkyne, we have 2 carbons, and it gets a little bit funky when it comes to the line structure of these alkynes, because we have our 2 carbons at either side of our triple bond, and then we just have hydrogens. So, in this particular case, because of that triple bond, each carbon only has 2 electron domains around it. And so this is going to have a linear geometry, and this angle is going to be 180 degrees. And so when you're actually drawing an alkyne, you see the name, you know it's an alkyne, you probably want to draw that triple bond first, make sure that linear geometry is holding around that triple bond, and then draw the rest of it in. Because of the way your curriculum is set up, regardless of whether you're taking an IB course or not, you pretty much are going to be expected to draw these structures properly with proper Vesper counts. Other than this, there's nothing super special about an alkyne. Same rules when it comes to putting in ones or not as alkenes, and same rules around numbering as well. So here you go. Pause the video, try and draw it out. Alright, so we have our parent chain, it's No9, and so that's going to be 9 carbons, and there is a triple bond on that first carbon. So if we're going to do my usual line structure, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I did this so that I can put that triple bond in, so our carbons are 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's put everything else in. So we have our 5 methyl. So 1, 2, 3, 4, 5. 5 has a methyl group. And then 5, 6, 6 tripropyl. I didn't plan properly, so I'm shifting that over a bit. So propyl, so 1, 2, 3 carbons on that carbon 5. Also on the carbon 6 and also on the carbon 7. As you can see, some of these angles might look a little bit wonky, but as long as you're making sure your carbons are distinct, that'll be fine. And once again, pause the video and try naming this one. So here we are going to highlight our parent chain. It is going to go this way because it's our longest chain that contains our parent functional group. We're going to number this. We have to start numbering from this side because that'll definitely give the lowest number combination for that triple bond. Then we have our side chain that has 3 carbons in it, so this is a propyl group. So let's put this all together. Side chains first in this case, so we have 4 propyl, and then we have 8 carbons in that chain, so it's going to be oct. We have our triple bond in carbon 2, and then it's a triple bond, so it's ine. Now the last thing that I'm going to go over in this particular lesson is a little bit of weirdness when it comes to whenever you have more than one of your functional groups in the main parent chain. So this is specifically for that main parent chain and any functional groups that have to do with it. So here we have 5 carbons, it's a pentene, we have 2 of those double bonds. So if we're going to number this, it's going to end up like this. Your name, it doesn't have anything else, so your name should look something like this. Now when it comes to your double bonds, you're going to do the same thing as you have in your side chains. You're going to put in the relevant numbers, and you're going to use those good old prefixes to indicate how many of the thing you have. Now, the weird thing is, if you only had one double bond, this would have just been pent, number, ene. But if you have more than one of it, for some reason the A comes back in. I don't know why, but it does when you have more than one of it. It's weird, but this is something that can show up. So that's the end of this lesson. I'll see you next time.